coal, oil, and natural gas add large amounts of carbon dioxide and other gases to the atmosphere. These gases absorb extra heat from the sun. If we're not careful, then our cozy, comfortable Earth will become too hot for life to survive at all.
If we didn't have an atmosphere to regulate temperatures, what celestial body might we resemble most? Well, our moon for one. Our moon doesn't have an atmosphere, so temperatures are extremely hot on the side that faces the sun, and extremely cold on the side that faces away from it. I can't take this. The pressure's too much for me.
What in the world are you talking about?
I just read that air actually has weight, and it's all pressing down on me right now.
Yes, it's true that air has weight, and that because of gravity, all the air above you feel pushing down on you. But you don't actually feel it.
Why not?
It's like this. Air pressure is always pushing on us from all sides, about 15,000 pressures for every square inch. But at the same time, our bodies push back against the air pressure with equal force. So it balances out and we don't get crushed.
I wish I could see all this.
Well, think of it this way. The air molecules near the ground is being packed tightly together by the weight of the air above. This is why air is much denser at sea level. But higher up in the atmosphere, there's a lot less air pushing down from above, so the air molecules are not packed together so tightly. Normally, we don't feel any of this unless the pressure changes suddenly.
You mean like when your ears pop in an airplane?
Exactly. At much greater heights, there is less air being pressing on you. Your body is reacting to the pressure change.
Scientists use barometers and other tools to study the air pressure, to predict the weather, and to study climates. You can measure changes in air pressure too. First, we can do an easy experiment to see how air expands as it gets warmer. Take a balloon, blow it up slightly, and attach to the top of an empty soda or water bottle. The larger the better. Put the bottle in a freezer. Meanwhile, get a sink or tub of very warm water ready. After 10 minutes, take the bottle out of the freezer. Observe the size of the balloon. Quickly submerge most of the bottle under the very warm water. Hold it in the water for at least 30 seconds. Observe the size of the balloon now. This is because the air inside the balloon is warming up and expanding. Just as warm air in the atmosphere expands, gets lighter, rises, and creates a low pressure area. Now let's make a real working barometer, which can measure the same effect in the atmosphere. To build a homemade barometer, you'll need a very large balloon, scissors, a large jar with a wide mouth, packing tape, a drinking straw, glue, some paper, a pen, a ruler, and a small poster board triangle. Cut off the balloon's neck and stretch it over the mouth of the jar. Seal the balloon to the jar with tape and make sure there are no leaks. Insert the small triangle into one end of the straw. Glue or tape the other end of the straw to the center of the balloon lid. This will be your homemade barometer. Put a piece of paper on the wall next to your barometer's pointer. Make a note of where the pointer falls. This is how you can measure the changes in air pressure. Check the position of the pointer every few hours, each time writing down the measurement. If the pointer moves down, it's because there is less atmospheric pressure pushing down on your balloon barometer. And if the pointer moves up, it's because there is now more atmospheric pressure pushing down on the balloon. weather with storms and precipitation. When the pressure is high, it usually means good weather with clear skies.
You know, Malcolm, if our Earth was the size of an egg, then our atmosphere would only be about as thick as an eggshell.
Don't start with food analogies. I'm getting hungry again.
My point is that our atmosphere, as thin as it is, can still be broken down into 4 main layers.
Examples, please.
Okay, we live in the troposphere, the layer closest to Earth. The troposphere goes up about 12 kilometers, which is about 7 miles. All the Earth's weather occurs here. The next layer up is the stratosphere. At the very bottom of this layer are very strong winds that blow eastward. This is called the jet stream. When large planes fly from west to east, they often hop into the jet stream. That extra push of wind from behind allows them to fly faster.
Ooh.
Also in the stratosphere is the ozone layer. Ozone is a special kind of oxygen that absorbs most of the sun's harmful radiation, like ultraviolet rays, which cause sunburn.
Without the protection of the ozone layer, few living things could survive on Earth.
Scientists have discovered a hole in the ozone layer over the South Pole. They're concerned that certain chemicals such as chlorofluorocarbons or CFCs from aerosol sprays and refrigerators may cause this.
Bummer.
If the hole is any larger, that means more radiation will reach Earth, and there could be potential problems for the future. So it's really important for us all to keep our atmosphere healthy.
Important stuff. Okay, so you've got the troposphere and the stratosphere. Any other spheres?
Sure, the mesosphere, the next layer up. It's the coldest region of the atmosphere, around minus 100 degrees Celsius.
That's minus 148 degrees Fahrenheit.
Unmanned balloons are often sent up to measure the temperatures of this layer. The mesosphere protects Earth from large rock-like objects from space called meteoroids. When meteoroids enter, the friction between the meteoroid and the mesosphere causes most meteoroids to burn up.
Yow! Hot stuff!
Have you ever seen a shooting star? A streak of light in the night sky? If so, did you know you weren't really seeing a star? Instead, you were witnessing a meteor burning up in the mesosphere. Occasionally, large numbers of meteors enter the Earth's atmosphere and burn up, all at the same time. This is called a meteor shower. It's a great show, and you don't even need a telescope to see it.
The thickest layer in the atmosphere is called the thermosphere. It starts at about 80 kilometers above the surface.
Or 50 miles.
Here, the ultraviolet radiation from the sun turns to heat and causes the air to be very hot, up to 1,500 degrees Celsius or more. Now scientists break the thermosphere down into 2 more layers.
Sneaky devils aren't they?
What's so sneaky about calling the lower part of the thermosphere the ionosphere?
I don't know. Why do they call it that?
Because when the sun's radiation reaches this layer, the particles become electrically charged or ionized.
Aha! Ionized! Ionosphere! Very clever.
These electrically charged particles can cause the sky to glow. This is called an aurora. In the northern hemisphere, these glowing particles are also called the northern lights. The upper part of the thermosphere is called the exosphere. It starts about 550 kilometers or 342 miles above the surface.
Exo means outer in Latin, right?
Yes. And the outer atmosphere is so thin here that one molecule of air can travel great distances without coming close to another molecule. This is the area where satellites such as communication and weather satellites orbit the Earth.
That's it. All ready to go.
What are you doing?
Shh. Don't scare her. This is Roxy. She's part of my special project.
What special project?
I'm trying to recreate the atmosphere just as it was when the Earth began to form. So Roxy is going to supply me one of the key ingredients. Oxygen.
But you're overlooking one important thing.
What's that?
When the Earth began to form about 4 billion years ago, there was no oxygen to breathe. Instead, gases such as water vapor, carbon dioxide, nitrogen, and really poisonous ones like ammonia and methane escaped through volcanoes and other cracks in the Earth's crust. Over time, most of the ammonia and methane gases disappeared, but there was still no breathable oxygen.
So where did it finally come from?
This is where the green plants come in.
Yay, Roxy!
Well, not so fast. This actually began with algae and some other very simple forms of plant life. As plants grew and evolved over billions of years, the oxygen content of the air increased. You see, plants, through photosynthesis, use carbon dioxide to create sugar for food. In the process, they release oxygen into the atmosphere. So the more plants, the more oxygen.
Boy, the Earth's atmosphere has really changed from when it was first formed.
It's always changing, even today. I'm telling you, no other planet in the solar system has an atmosphere like ours. Take our neighboring planet, Venus, for example.
Okay?
It's solid and rocky like Earth and has an atmosphere. But its atmosphere mainly consists of carbon dioxide. And on Venus, there is so much carbon dioxide that very little of the sun's energy escapes back into space. This is why surface temperatures on Venus are hot enough to melt land.
I'm sweating just thinking about it.
I've wondered, we have carbon dioxide on Earth. Can ours be like Venus's atmosphere someday?
148.
Our atmosphere could be like Venus's. It produced too much carbon dioxide from the burning of fossil fuels, and heat could build up in Earth's atmosphere as happened naturally on Venus. And we could live with it.
Jupiter is the largest planet in the solar system. Even though it is made entirely of thick gases, no solid land, it still has an atmosphere.
I can't imagine wanting to breathe in Jupiter's atmosphere.
No kidding. It is rich in hydrogen and helium gases instead of nitrogen and oxygen like Earth. Then there's planet Mercury that has almost no atmosphere. Without the protection of an atmosphere, temperatures are burning hot during the day and freezing cold at night. The intense cold of space would quick freeze at minus 271 degrees Fahrenheit. Keep it up. I thought you were helping me do research, not watching TV.
I'm getting the weather report.
Malcolm.
Did you ever notice how some meteorologists have funny nicknames? I'm changing my name to Rain.
I think you need some fresh air.
Weather can be crazy. It can change so fast in the same place.
It also changes every season, but you can thank the Earth's axis for that.
Thank you, Earth's axis. Why am I thanking the Earth's axis?
Because it's tilted. You see, because Earth is tilted a little to one side, different amounts of sunlight reach different parts of the surface throughout the year. As Earth revolves around the sun, one half always tilts toward the sun, and one half tilts away from it. The half that is tilting towards it receives more sunlight and experiences summer. Meanwhile, the other half receives less sunlight and experiences winter. And 6 months later, the Earth has orbited to the other side of the sun. Now conditions are reversed. Where it was summer, it is now winter. And where it was winter, it is now summer. On or near the equator, where the northern and southern hemispheres meet, the sun shines more often and more directly throughout the year. That's why it's usually warm at this part of the Earth.
Okay, so seasons have to do with the tilt of the Earth. But what about days
with a bunch of factors such as temperature, wind, humidity, and cloud type. But it all starts with the sun. See, sunlight warms the land, the water, and the air above it. Warm air rises and carries water vapor that has evaporated from rivers, lakes, oceans, and plants. High up in the atmosphere, the air cools and condenses into tiny water droplets that form clouds. As more and more water vapor collects in the clouds, the droplets eventually become heavy and fall back to Earth as precipitation, like rain or snow. High atmospheric winds push weather around the Earth, bringing rain to dry land, moving warm air to cold areas, and cold air to warm regions.
You've probably heard of airplanes that actually fly into hurricanes. Let's meet one of the people who does this for a living.
My name is Wayne Wright. I'm a scientist with NASA. I fly on the NOAA Hurricane Hunting P3. P3 is a big 4-engine airplane that can fly for a very long time. It can fly high or it can fly low. And in hurricanes, they normally fly about 1 mile above the ocean. And we fly back and forth in and out of the hurricane, locating the center of the hurricane each time we go through the eye of the storm. The big thing inside has instrument racks, big boxes with equipment in them. One of those pieces of equipment is my radar.